So we're going to take a look at proving triangles in the coordinate plane. It's actually just like quadrilaterals, only it's triangles. So pause the video and copy that down. Alright, so a different kind of triangles. First one we're going to look at is a right triangle. It makes an L shape. Okay, it has a box called a right triangle. This is a listening check, shading the right triangle. Next one we're going to look at is an isosceles. It has two equal sides and the two base angles of those sides are also equal or congruent. Isosceles. Then the next one we're going to look at is a scalene, meaning none of them are equal. None of the sides are equal. I did forget one, but I'll put it in later. The area of any triangle is a half base times height. It's going to be available in your formula sheet, so you don't have to remember. Alright, so we're going to take a look at this question, and we're trying to show what kind of triangle it is, whether it's scalene, isosceles, equilateral, or right. So clearly you're going to go ahead and graph the coordinates. So your triangle looks like this. So it looks like it's a right triangle at the very least, but we're not going to make any assumptions. You have to, when you're attempting to prove a right triangle, you have to prove that it has a 90-degree angle, which means you have to know the slope of those two lines are perpendicular. When you try to prove isosceles, you have to prove that two sides are congruent. So that means that you're using distance. And when proving scalene, you have to say that all sides are not congruent, so you have to find the distance of all sides. Right, there's one more that I forgot to draw initially, which is an equilateral triangle. Equal, equilateral, equal. That means all the sides are congruent. So you're going to use distance to prove that all the sides are congruent. Equilateral triangle. This is a listening check, shading the word distance. Okay, so let's go ahead and answer this question. So I'm going to find the distance because it all has to do with distance. I want to find all the distance, A, B, BC, and CA, or AC, same thing. Alright, so remember the distance formula. You can get that off your reference sheet, so just copy it down. And then all you're doing is plugging in the points. So open parentheses, 0 minus 0 squared plus y2 minus y1, 0 minus 6, close parenthesis squared. Alright, second one, same thing. Open parenthesis, x2 minus x1, negative 8 minus 0 squared plus y2 minus y1, 0 minus 0 squared. Last one, same thing. X2 minus x1, that's negative 8 minus 0 squared plus 0 minus 6 squared. And then you just punch in that in the calculator. So literally just make sure that when you punch in the calculator, it matches exactly what you're punching in. And if you're still struggling with doing this, then just watch the previous videos. This is a listening check. Put a box around CA. Put a box around CA. So we get a distance of 6, 8, and 10. Right. And now I'm going to check if that, because it looks like it's a 90 at AB is perpendicular to AC. So I'm going to check to make sure. So with that, I need the slope. So I need to find the slope of AB. So I'm writing the coordinates down. And then the slope of BC, and I'm writing those coordinates down. Change in Y over change in X. So from 6 to 0, what do? Negative 6. Then from 0 to 0, plus 0. And if you do negative 6 divided by positive 0, you're going to get an error because it's a vertical line. So it's a vertical slope. I'm just going to show you that in a calculator. Listening check, put a box around the word error. Cannot divide by 0. It's just you need to remember it's a vertical slope. This one is going to be plus 0, change in Y, and then 0 minus 8. And that's going to be 0. 0 divided by anything is 0. And that means a horizontal slope. So when you have a slope of 0, it's horizontal. When you have an error, it's vertical. Which proves that that is 90. Because a horizontal and vertical line meet at 90. So this is a scalene because, again, none of the sides are equal. So a scalene right triangle because all the sides are not congruent and AB is perpendicular to BC. Sometimes when you're doing your test or whatever, you have to explain why you know it. So you have to be able to put that into words. Right, then we're going to look at the area. So the area is a half times the base times the height. The base is 8 BC and the height is 6, which is AB. And then a half times 8 times 6 is 24. Then to find the perimeter, you add all the numbers around. So it's going to be 10 plus 6 plus 8, and that's going to be 24. And that's pretty much all there is to it. Right, so another question, prove that it's an isosceles right. So to look at isosceles, you need the two distances are congruent, and a right, you need to find the slope is perpendicular. So I'm going to write that down, because remember, our first thing is always, what do I need to do? Then I need to sketch it. So I need to prove that two sides are congruent and one is perpendicular. Let me go ahead and sketch that. And this is just a rough triangle, it's not even the numbers. I'm just sketching the isosceles, right? And then label it in order QRS. So I need to find the distance of QS, QR, SR. Alright, and all I'm going to do is plug it into the distance formula. So x2 minus x1 squared plus y2 minus y1 squared for each one. This is a listening check. Color in the coordinates Q, 4, -1, R, 5, 6, S, 1, 3. Color in those coordinates where my fingers of my left hand are. And then you're going to go ahead and just punch it in the calculator, make sure it looks exactly the same. Sometimes I wonder if you're really listening, or if all of my words are just leaving my mouth floating. Alright, so that's going to be distances of 5, 7.07, and 5. Alright, so you can see two sides are equal, so QS is congruent to SR, so I'm going to label that, and then the other one is 7.07. And then I'm going to check to make sure that QS is perpendicular to SR, because remember, the two base angles are congruent. That means that one has to be the right angle. Because the two base angles are congruent, they can't both be 90, because 90 plus 9 is already 180, and you need the third side. So I'm going to check that QS is perpendicular to SR. So again, I'm going to write down the coordinates, then I'm going to do of QS and SR. And then I'm going to do change in Y, which is plus 4, over change in X, which is -3. And that simplifies to -4 over 3. And then on this side, 3 plus 3 will give me 6, so that's plus 3. And then 1 plus 4 will give me 5, so that's plus 4. Simplify that as 3/4. This is a listening check. Color in the two slopes that we found. Alright, so remember, check perpendicular, you have to flip it and change the sign. So take the first one, flip it, 3 goes on top, 4 on the bottom, change the sign, becomes positive. If you do it the other way, you flip it on the bottom, it becomes 4 over 3 and negative. So either way, whichever way you're doing it. So two sides are congruent and it's 90 degrees, or rather it's perpendicular, therefore we can conclude, and sometimes you actually have to write this out in a question, so we can conclude triangle QRS is an isosceles right triangle because two sides are congruent and it has one right angle. And we just proved that. Now to find the area is a half base times a height. Half and the base is 5, and the perpendicular height is 5. So remember, height has to be perpendicular, because when you go to the doctor's office you don't slant. It has to be vertical. Alright, so that's going to give me approximately 12.5, and then the perimeters, you add all the numbers on the outside, 5 plus 5 plus 7.07, and that's roughly 17.47. And that's pretty much it. So let's practice.